Hello everyone, we are group 44 and today we are going to introduce the IEQ credit 9, which is the acoustic performance. The intent of this credit is to provide workspaces and classrooms that promote occupants' well-being, productivity, and communication through effective acoustic design. There are three main points behind the intent. This credit challenges project teams to address best practices in acoustic design as an indoor environmental quality imperative that complements other green building practices. Second, the credit challenges project teams to balance acoustical design strategies with considerations for daylighting, thermal comfort, and other performance areas that must be considered when planning systems and indoor spaces. Third, in all project types, well-designed acoustics can enhance the environmental quality of the space by facilitating communication, increasing productivity, improving the well-being of workers, or aiding in noise control and speech privacy. The requirements for new construction data centers, warehouses, and distribution center and hospitality require all occupied spaces to meet the following requirements as applicable for HVAC background noise, sound isolation, reverberation time, and sound reinforcement and masking. For the HVAC background noise, it is required to achieve maximum background levels from HVAC systems per 2011 ASHRAE handbook and other requirements or a local equivalent. For measurements, use a sound level meter that conforms to ANSI S1.4 for Type 1 precision or Type 2 general purpose sound measurement instrumentation or a local equivalent. The sound transmission requirements is to meet the composite sound transmission class STCC ratings listed in Table 1 or local building code, whichever is more stringent. For all large conference rooms and auditoriums seating more than 50 persons, it is required to evaluate whether sound reinforcement and AV playback capabilities are needed. For projects that use masking systems, the design levels must not exceed 48 dBA, and it is required to ensure that loudspeaker coverage provides uniformity of minus or plus 2 dBA and that speech spectra are effectively masked. The requirements for HVAC background noise for schools is to achieve a background noise level of 3.5 dBA or less in classrooms and other core learning places. The requirements for sound transmission for schools is that design classroom and other core learning spaces to meet the sound transmission class requirements of ANSI S12.60 bar 2010 Part 1 or a local equivalent. Exterior walls windows must have an STC rating of at least 35, unless outdoor and indoor noise levels can be verified to justify a low rating. The requirement for healthcare is that design the facility to meet or exceed the sound and vibration criteria outlined below, which are adapted from the 2010 FGI guidelines for design and construction of healthcare facilities and the reference document on which is based, sound and vibration design guidelines for healthcare facilities. The option 1 for healthcare requirements is speech privacy, sound isolation, and background noise. For speech privacy and sound isolation, 3 steps are required. First step is consider sound levels. The second is to design the facility to meet the criteria. The third is to calculate or measure sound isolation and speech privacy descriptors. For the background noise, the first step is to consider background noise levels, then to design the facility to meet the criteria, and the third step is to calculate or measure sound levels. The option 2 is acoustical finishes and site exterior noise. For the acoustical finishes, firstly is to specify materials, products, systems, installation details, and other design features to meet the guidelines. Then it is to calculate or measure the average sound absorption coefficients to confirm conformance with the requirements. For the site exterior noise, there are several steps. First is to minimize the effect on building occupants of site exterior noise produced by road traffic, aircraft flyovers, railroad, and other. Then it is to minimize effects on the surrounding community from all facility MEP equipment and activities as required. Third is to comply with the 2010 FGI guidelines for the following noise sources, including heliports, generators, mechanical equipment, and building services. Then it is to measure and analyze data to determine the exterior noise classification of the facility. And the fifth is to design the building envelope composite STC rating based on the 2010 FGI guidelines. Categorization of healthcare facility sites by exterior ambient sound and show conformance with requirements. And lastly, for exterior site exposure categories B, C, or D, calculate or measure the sound isolation performance of representative elements of exterior building envelope to determine the composite sound transmission classes rating for representative facade sections.
Now we will move on to step-by-step guidance for new construction, data centers, warehouses, distribution centers, and hospitality. Step 1 is to define acoustic needs for each space. This can be done by determining two things: activities or user groups within each space, and privacy or sound sensitivity requirements. Step 2 is to review acoustic criteria. This can be done by evaluating the four following parameters: HVAC background noise levels, sound isolation, reverberation time, and sound reinforcements and masking systems. In step 3, we address HVAC background noise. In this step, we need to identify any equipment or air distribution elements that could contribute to HVAC background noise. In step 4, we verify HVAC background noise. For this, we have to determine noise criteria, room criteria, A-weighted sound pressure levels or C-weighted sound pressure levels for each occupied space. For determining these, we can calculate sound pressure levels in Chapter 48 during the design phase, or calculate the sound pressure levels as per AHRI Standard 885-2008 during the design phase, or measuring the sound pressure levels as per Chapter 48. This may be done during the pre-construction phase. Step 5 is to verify noise reduction methods for sound transmission paths. This can be done by highlighting each transmission path from Chapter 48, Table 6 in drawings. Step 6 is to identify adjacencies for sound insulation requirements. This can be done by reviewing Table 1 from the credit requirements. Step 7 is to verify sound insulation. This can be done by demonstrating compliance through published data, calculations, and measurements. Step 8 is to identify space reverberation time requirements using Table 2 in the credit requirements. In Step 9, we implement reverberation time mitigation strategies. We can use sound absorptive materials and other strategies for this. In Step 10, we verify that reverberation time requirements are met. Reverberation time must be verified at 500, 1000, and 2000 Hz. These calculations and measurements must be retained for credit documentation. In the last step, that is Step 11, We select sound reinforcements and masking systems if needed. This credit does not require that sound reinforcements or masking systems be installed, but if these are installed, they have to meet the specific system criteria. Following is the required documentation for this credit.